प्रेशर कुकर जैसे सर की बच जाए ना सीटी तब तक मार।
Hello, Assalamu alaikum. I am 191017 Yasir Zahid from Air University. In today's video I am going to talk about BCD to Excess 3 converter. Now BCD is basically code of the decimal counting in binary of 4 bit. Like here we have 000 to 1001. Now we can go up to 1111, but we count only up to 9 in BCD. So we have excess 3 of 8 here written in 4 bits. Excess 3 is plus 3 in binary: 0, 3, 1, 4, 2, 5, 3, 6, and similarly goes on. Now what we are going to do is implement the circuit using a mux. Mux is basically a wiring which has multiple inputs in overcase 8 inputs, and one of them is to be allowed at the output. Now the formula for the mux to use is, since we have 4 variables, so we will have n minus 1 equals 3 selection lines, and the outputs we are obtaining here, we can see them as different functions. So in short, we can say that we have 4 functions: 1 function, 2 function, 3, 4. To implement each function we need 1 mux. So to implement these 4 functions we'll need 4 mux. Now coming to what mux we will use for each function, we have 2 raised to power n minus 1, 2 raised to power 3, 8 ratio 1. We are going to use a 8 ratio 1 mux. Now to implement this, we are gonna use 3 of the inputs, 3 letter inputs, of which are V, C and D, as the selectors of the line, and we will supply A at these inputs I0 to I7. We'll use these inputs at the 8 inputs of mux. Now the technique used here is very simple. This defines what input are we supposed to give at the 8 pins of the mux we are going to use. In this technique, what we simply do is we'll go from 0 to 9, write the counting. Rest are don't care, so we cross them, and don't cares are 1 in case there is no circle up, and don't cares are not considered in case we are just getting this output. So what we have done here is we have circled the high inputs for the respective digits. Like for the first one we have 1, 2, 3, 4, 5, 6. We have first 5 zeros, then we have 5 ones. So here we can see that we have 5 zeros, 5 ones. Here we are. We here 5 zeros, 5 ones, and at output we have it as this digit 5 zeros, 5 1, and at input we have all zeros and last 2 as 1. We'll circle these right here. This one we have circled. We have not circled the first 5, and we have circled the last 5. 5 zeros and then 5 ones. And after that what we'll do is we'll simply match these. If there is only one circle in a row, for example here in a column we have only one circle, and that's for A, we'll write A, A, A. Now here we have circles for A dash, we'll write A dash. In case we have got no circles, we'll assume that don't cares are 1. So if these are 1, we'll write A, 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 and in case we have none, we have both of these circled, it becomes A, A dash, which becomes 1. Now the same, we have done the same procedure for first digit of excess 3. We are going to get second digit, third digit, and fourth digit. So here we have these codes A, and up to A dash, A dash, A dash. These 8 inputs 1. These are for first mux, these are for second mux, these are for third mux, and these are for fourth mux. we'll simply write them down beside mux. These inputs we got first mux, and then for the second mux, for the third mux, for the fourth mux. BCD are there being used as the selectors for the line, and D is the output digit. Now we'll implement this circuit in Proteus. I have copied the same diagrams in my Proteus. Now here is my circuit. What we have got here are the BCD inputs right here, and then here we are going to get the outputs from these mux. First digit and fourth digit from fourth mux. Now coming to the system we have used to implement this whole circuit, we'll just zoom in a bit just to compare the circuits. This is the diagram I got back there in the paperwork. Here we can see that all first 5 pins have A, all first 5 pins here have A, then we have at last 3 pins A0, we have got here A0, here we have got A, B and C at these 3 pins. This is low active, so we have given 0 here to make this active. Similarly for the rest of 3 we have matched these diagrams along with this that we got in paperwork. First one has 0, first one has 0, this 1, 2, 3, 4, these pins are same, 1, 2, 3, and this one 4, these have same. So we have matched all the inputs right here. Now we are simply going to run this. We are simply going to run this simulation to simulate how it's working. Now at this we have supplied 0, and at output we have got 3. Now similarly here we have got now 1, then there we have got 4, then here when we apply 2 we get 5, we apply 3 we get 6, we apply 4 we get 7, 5 we get 8, 6 we get 9, 7 we get 10, and after that we have 8, and what we get at output is 11, and we apply 9 and we get 12. So this is the simulation of conversion of BCD to excess 3 output using these 8:1 mux. Now we could have done the fourth variable as inverse of this and this are always inverse of each other, but I've used the whole procedure to implement the fourth function. Actually everything depends on these 8 inputs we are supplying here, because we are using A as the guider for what we get here as the output. So the only thing we have differentiated at these points is the input we are giving, whether it's A, A-1 or 0. This was all for this video. Thank you. Allah Hafiz.
प्रेशर कुकर जैसे सर की बज जाए ना सीटी तब तक मार रट्टा मार